Before we look at addition or subtraction of real numbers, we need to understand a few basics first. Consider the nth root of a. It is written like this. N is called the index. This sign is called the radical and a is called the base. It's called the nth root of a. Until now, we have looked at numbers like these. We call this the square root of 7. So 7 is the base and this is the radical. But what is the index? It's 2. We do not generally write 2 here when we take the square root or the second root of a number. It's because we use it very commonly. So the radical without the index means it's the square root. So to write the fifth root of 12, we write the radical with a 5 here and the base 12 inside. The only place where we are allowed not to write the index is the second root or the square root. Can we add or subtract these two numbers? Square root of 7 and fifth root of 12? No, we cannot. What kind of real numbers can we add then? We can add or subtract the numbers only if they have the same base and the same index. Both these conditions have to be satisfied. Remember, same base and same index. They can be added or subtracted. So if we have two numbers like fourth root of 5 and 8 multiplied by fourth root of 5, can we add them? Yes, their base is 5 and their index is 4. Their sum would equal 9 fourth root of 5. This was the first important concept you had to understand before looking at operations on real numbers. Same base and same index can be added or subtracted. We will come to the examples later, but let us understand the second important concept now. It is the concept of the simplest form. What does it mean and why are we learning this now? Look at this number, root 8. What do you think is the base and the index of this number? Well, it's simple. The base is 8 and the index is 2 as it's a square root, correct? Now let's try writing 8 in terms of its prime factors. It can be written as root of 2 times 2 times 2. Since it's a square root, we look for pairs of same numbers. We can form this pair here and take one number out from it. That gives us 2 root 2. So the number root 8 can also be written as 2 root 2. They are equivalent. This is called the simplest form of root 8. Now you can say that the base is 2 and the index is also 2. What about cube root of 32? As we see it, the base is 32 and the index is 3. Writing 32 in terms of its prime factors, we get cube root of 2 times 2 times 2 times 2 times 2. Since it's a cube root, we take groups of 3 and take one number out from that group. We can make just this one group here. And what remains is 2 times 2, which equals 4. Hence, this will equal 2 multiplied by cube root of 4. This is the simplest form of cube root of 32. What does this tell us? Assume we are given two numbers, root 2 and root 8, and we are asked if they can be added. Well, you might think no, since their base is different, but as we saw, root 8 can be written as 2 root 2, and sum of root 2 and 2 root 2 will give us 3 root 2 or 3 multiplied by root 2. So before you solve any problem based on operations on rational numbers, it would be a good idea to first reduce the number to its simplest form and then proceed.